Hello and welcome to the course Understanding Network File System NFS. In this section, you will learn about the following topics: TCP Primer and Introduction to NFS. TCP/IP Primer. TCP/IP stands for Transmission Control Protocol and Internet Protocol. It is a communication framework for transport of data from one point to another. The correct word to use is a protocol instead of the framework. In simple words, a protocol is a set of rules which two entities must adhere to, without which communication cannot take place. An example will be when a German and an Indian person won't be able to communicate with each other or talk with each other unless two of them speak a common language, say English. TCP/IP is a common language that two or more networks must use to speak with each other. As with English, like we have American, Australian, and Indian English, TCP/IP has other associated protocols like FTP, which stands for File Transfer Protocol, and NFS, or Network File System. In fact, these protocols also use TCP/IP to render the services, because it is TCP/IP that transfers packets from one point to another. The web protocol HTTP or Hypertext Transfer Protocol also uses TCP/IP, which means that the internet is driven by TCP/IP. Introduction to NFS. NFS was developed by Sun Microsystem and is implemented by many vendors. It is a file service protocol. NFS facilitates a system to share its directories on the network, which are then mounted across other systems or computers running the client version of NFS implementation. The system that shares its directory must run the server level implementation of NFS. When the directories of the NFS server are mounted on the client system, they act as if they are part of the local directory system. In short, NFS is a distributed file system protocol that allows the sharing of directories across the network. A practical real-life example is when you install a production-ready software on a server running the NFS server daemons, and then make it available to the client nodes to mount. In this manner, many clients will access the software that you have installed on one machine. Imagine the time you will save not installing the software on each client system on your network. Of course, there is a downside. If the server machine fails, all clients are rendered useless. This is a single point of failure which can be alleviated or solved using RAID, or redundant array of inexpensive disks. NFS theory. NFS is not a standalone protocol. It is closely associated with TCP/IP and uses a range of protocols to service its client-server architecture. To understand the concepts, we must refer to the OSI model. The International Organization of Standards, or OSI, developed this landmark model in 1978 with the aim of using it as a basis to create open systems, and that different architectures should adhere to a common set of rules for communication. Because during those tumultuous early period, vendors created proprietary architecture. The real reason, which of course is my opinion, is that the vendors used such tactics to give less choice to customers and protect their businesses. But following the OSI model ultimately proved beneficial, paving the way for heterogeneous architecture and allowing interoperability. As you can see, the OSI has 7 layers: physical, data link, network, transport, session, presentation, application. The top layer is the application layer and corresponds to applications protocols such as FTP, NFS, the now dreaded Telnet, HTTP. Consider a grain of sand that needs to traverse from the physical layer and to the application layer. As it crosses each layer, imagine a coat of paint added to it at every layer until it becomes a pearl when it reaches the top layer or the application layer. The grain of sand is of course an analogy for the bit of data. In a reversal, when the pearl travels down, each coating is stripped off until it becomes the lonesome single grain of sand again, or that single bit of data. Physical layer. As the name suggests, it deals with the hardware that includes cables, the network card, wireless or wired network. The layer deals with bits of data in the form of zeros and ones, called digital communication. The layer is not bothered what these bits represent. It could be files or database records or ping echoes. As for NFS, it supports all the underlying hardware components of the physical layer. Data link layer. The bits from the physical layer are grouped together into frames. For examples, the bits may adhere to the Ethernet protocol frame format. The frame is a sort of an envelope in which your data resides. And like a real envelope, the frame consists of address, control, data, and error control fields. For example, the address field has both the source and destination IP address for the data it is carrying. The main function of this layer is to pass the frames to the next layer, the network layer. As with physical layer, NFS also supports the logical framing services of the data link layer. Network layer. The logical groups of bits called frames in data link layer are now called packets, and the network layer facilitates routing of packets between the two nodes. Besides routing of packets, the network layer enables connectivity between two different types of networks. This is also the layer which is associated with IP or Internet Protocol packets, because it is the IP packets that carry data and then reassemble the packets at the destination. NFS is of course more than happy to use IP packets. Hello, we are still with the OSI model, and now we are going to know about the transport layer. This layer is all about data integrity and error control mechanism. It can be considered as an extension of the network layer, but with more emphasis in error control. If the previous layers have failed to provide better error control to the packets, it falls upon the transport layer to provide the necessary services to compensate this lack. The two protocols associated with transport layer are UDP or User Datagram Protocol and TCP. Earlier versions of NFS used UDP like version 1 and version 2, but later versions of NFS like NFS 2 started to support TCP. While UDP or User Datagram Protocol is fast, it is not reliable. TCP was considered slow because it added error control mechanisms to the packet. UDP is faster because it does not employ error control and sends no acknowledgement for data delivery. TCP is bogged down by error controls and sends acknowledgement to the sender. Session layer. As the name suggests, a link or a session is established between two nodes in this layer. The layer provides a mechanism for dialogue control between two communicating nodes. For example, if you are downloading a file from a remote system and the connection terminates due to a network outage, a control mechanism called synchronization checkpoint built in the packets is referred to, so that when network connectivity is restored, you can start downloading from the point it lost the communication. A protocol that provides more services than the regular TCP/IP and is used by NFS extensively is the RPC or Remote Procedure Call. However, many other applications protocols do not need to adhere to the standards dictated by the session layer. NFS uses RPC because RPC is a set of libraries that provide an abstraction layer from the lower OSI layers, while giving access to NFS to higher levels such as presentation and application layers. Remote procedure calls are implemented by NFS. They are specialized programs that deal with transfer of data and control commands. Initially, these commands were used in application on a single computer, for instance, copying a file from one directory to another. Over time, the folks at Xerox thought that they can be implemented over the network as well. If you want to know more about RPC, then Google for RFC, request for comments, number 1831. Presentation layer. This is the layer that concerns how the data presented to you looks. NFS uses XDR, External Data Representation Protocol, in this layer. Finally, the application layer. Application programming protocols, or APIs, form the basis of this layer. They are libraries that developers or software developers use to create network applications. The services provided by this layer are followed by most of the applications like NFS, HTTP, FTP. So the services that application layer provides are: 1. Providing libraries that enable read and write into remote hierarchies or directories. 2. Executing commands on remote locations. 3. Enabling messaging between nodes. Thank you.